Hi, hello everyone, and welcome back to my YouTube channel Spotify Learn. Today I'm here with the fourth module of BCS301, that is Mathematics for CSE stream, fourth module. Three modules are already completed. If you have not watched, please watch that three videos and then come here so that you will gain a bit of confidence about the subject. As you don't have much gaps between the exams, you need to prepare now itself perfectly so that later no need to worry about that. You can get this PDF also with solution, that is it is handwritten. You can DM me on Instagram. I'll mention my Instagram account in my description box. Come, let's start with the video without wasting the time. See, we have to learn about the central limit theorem, confidence limit, test of significance, star T distribution, chi square, and the F distribution. Okay, now we will see first what is central limit theorem. What does it states? See, the statement is given here. It states that the sample mean x bar, that is x bar is what sample mean, follows approximately the normal distribution. It will follow the normal distribution with mean mu, standard deviation sigma by root n, that is also called standard error. Now that will be equal to x bar minus n of mu comma sigma by root n, where mu and sigma is mean and standard deviation. This is the formula that we have. You just explain what is the term. X bar is mu is what mean, sigma is what standard deviation, number of samples and all, that is of the population from the sample. This statement you can study easily. I'll explain the problems about that. An electrical firm manufactures light bulbs that have a length of life that is approximately normal distribute with mean 800 hours and SD 640 hours. Find the probability that a random sample of 16 bulbs will have an average life of less than 775. They have said less than. Okay, keep it remembering. Okay, now what they have given, 16 bulbs are there, so write n is equal to 16. And average life, what that means, mean is what, average, right? So they have given 800, you write it, and directly they have mentioned standard deviation as 40. You take sigma as 40. Now they have asked for what, less than 775 hours. When you have to do for less than, first you find out at 775 and substitute the value of x bar is 775 and rest all values you know, and you will get minus 2.5. If you get this minus 2.5, you can find easily about the less than for 775. That is, it should be less than minus 2.5. That means it should be less than minus or greater than plus. Okay, that is the logic here. Now if you take that 0.5 minus, see here, 0.5 minus 5 of 2.5, 0.5 minus, this is according to the Z table, you know, right? That Z table will be there. According to that, if you see, 4938 will be present. Now if you subtract, you will get it as 0.0062, that is almost equal to 0 itself, but you will take it as 0.0062 for less than value. Now you have to find out, an unknown distribution has a mean of 90 and standard deviation 15. N is equal to 25 are drawn randomly from the population. Find the probability that the sample mean is between 85 and 92. Okay, now you write the what are the given values. Again substitute, x bar is not given here, right? So you have to substitute between what they have asked, 85 and 92. For both you have to substitute for x bar. Okay, I hope you got this. X bar, after you substitute, you'll get minus 1.5 and plus 0.66. Okay, now that the range will be from that. Okay, now if you find out 85 to 92, right, x bar, that is less than 92 and greater than 85. Now you will take the probability as minus 1.66 and less than, I hope you are getting. First I'll explain this question again. First, what you have taken, they have given 85 and 92 for x bar value. That means you will take x bar as what, 85 for first and 93 for second. That is how you take. Here it will be, it's 1.66. Okay, now the same way you will get, and minus 1.66 till plus 0.66, the difference will be 1. If you take as less than, you will get, and according to the Z table you will get the value as 0.6965. Again, the third question is a random sample of size 64 is taken from infinite population having mean 112 and variance. If they have given variance, you have to do root for it, you will get the standard deviation. They have mentioned using central limit theorem find the probability. They have given greater than 114.5. Okay, in order to find, you will just substitute in the formula, that is x bar. If you substitute, what is the value you are going to get is 112 by 1.5 you will get, and 114.5, as I said here they have given 114, you have to find, and you will get it as 1.66, and then you have to find out for greater than 114 point, they have asked here greater than. Okay, next you will get it as 1.66, that is greater than this z value, right? Next, if you get 0.5 minus the value of 1.66, z table is 0.4515, you will get it as 0.0489. This is the value you get for this. Next, we will move on to the topic confidence limits. I hope central limit theorem is perfectly clear. You first learn the statement, and then if you solve these three problems, it's more than enough. Even the numbers may change, but the sampling or any type of questions will be same again. Now, a random sample of size 25 from a normal distribution sigma square, that is what they have given variance, yields sample mean x bar is equal to 78.3. Obtain a 99% confidence limit. As I know, as you know from last module we studied, 99% means what? 2.58. If they give 95%, what it is? 1.96. If you remember this, almost the problem is done. Okay, now let's discuss what is the n given x bar. That n is 25 and x bar is mean, they have given as 78.3. Now if you have to find out the confidence level, that what they have given 99%, right? That means what is the z value, as I said, 2.58. Now if you find the 2.58, you will find out the confidence interval. If you want to find out mean plus or minus z of sigma by root n, that is you have to remember this formula. Okay, I'll square it and substitute all the values. Z value is this is 2.58, and if you will get plus and minus, and you first do minus then plus, because this will become minus means it will become lesser value, right? It will become lesser value, this will be greater value. So in order to match that, you will plus, first you will do the subtraction, then you do the addition, and you will get the corresponding values, that will be the factors for confidence limits. Now again they have given four samples taken from variance, they have given, and 95. For this, what you have to take? 1.96. N is equal to 4 because they have given first sample, second sample, third sample, and the fourth sample. If you take the average of that, that means add all and divide by 4, you will get 14.25. And you have to find out the standard deviation, that is root of 6.25, you will get 2.5, and for 95% it is 1.96. Again you will substitute here and you will get plus or minus. First you do minus, then you do plus, you will get two values, that is the factors for the confidence limits given. Confidence limits, this is how you solve about the confidence limit. Just remember, for 99% it is what? 2.58. For 95% it is what? 1.96. Next comes is most important topic of this module. One second. Sorry for the interruption. That is test of significance. Below are the weights of the cows fed on two diets A and B. They have given gains of weights of two cows. Okay, and they have given it as diet A and diet B. Now in order to do that, first you have to take what? Null hypothesis and the alternate hypothesis. Null, what you will consider? The it is no difference, and you will consider no difference, that means between the two sample, if you take two sample, there is no difference between them. Next, if you take n1 is equal to 12, that means n1 is where what? Here, and 1 2 3 4 5 6 7 8 9 10 11 12 are there. Here 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 are there. Okay, now Again, if you take the value of sigma x1, that is, add all these elements, add all these, again add all these, you will get it as 336 and 450. Again, if you have to find out the x1 bar, you will take it 1 divided by n1, sigma is equal to 1 to n x1I, that is 336 by 12, that is 28. Again 480, that is 480 by 15 will give you what? 30. 450 it is, okay. If you add this, you will get, it is what? 450 divided by 15. Now again you subtract x 1 minus this whole square. If you do, you will get 380 and 1410. Now because of LOS, right, level of significance is mentioned 5%, that is n1 plus n2 minus 2 degrees of freedom, that is you will take t value, that is 0.05 for 5%, and 12 plus 15, that is n1 n2 value minus 2 will be what? This will become 27, minus 2 will be 25, and the degree of freedom is 2.06. Now if you substitute in this formula, that is sigma, this already we have found out here and here, that you will get it as 71.6. now you have to find out the t value, right, that is x1 bar minus x2 bar, s square of 1 by n1 n2, all the values you have, just you have to substitute. That will be what? Minus 0.61. if you take out mod is nothing but if you have some minus 1 value, if you take out this mod, it will be plus 1, that is removing of negative sign in the particular question. Now you will get it as plus 0.61. Next, the degree of freedom will be what? 25, right? That is, take the value of 25, you will get it as 2.060, right here. 2.060 is answer. But the calculated value which you have calculated is 0.61. It is less than this value, degree of freedom for 5%. So we will accept the hypothesis. We will conclude that it does not differ significantly as regards. Okay. This is, if it is accepted, it will not. If it is rejected, it will accept. Next, sample of two types of electric light bulbs were tested. For length of life, following table were obtained. See, type 1 is there, type 2 is there. What are these they have given? First, you consider null hypothesis as no significant. Then you consider x1, that is x1 bar. You will get it as 1234, x2 bar 1036. Again the same formula you need to apply. Again x1 bar, x2 bar, all the values you have here, it will be greater which you have obtained the value of t, so it will be rejected. Okay, this is how we do these type of problems. I hope you understood this, that is text of significance. It is one of the most important topics. If you have any doubts, you can let me know in the comment section. Next is about the students' t distribution. 10 individuals are chosen at random from a population, and these heights in inches are found to be 63, 63, 66 at 10 samples they have given. Test the hypothesis that the mean height of the universe is 66 inches and they have given the value for t. If this, like this value they have given in the bracket, that means it is t, student t distribution, and they have given for 9 degree of freedom. You consider how many heights they have given? 10. N is equal to 10. Mu is equal to 66, that is mean. Next, you have to say let mu is equal to 66 inches. That means t will be what? X bar minus mu divided by 3. That is, you are calculating, okay, calculated value into root n. You will substitute, and x bar will be what? X, that is all the x value by n. That will be 67.8. Again, s square will be what? 1 by n minus 1 sigma of x minus x bar whole square. This you will get the value. Just you need to, I hope you got this. See, first they have given the value of 63, right? 63, 66, 67, and all the values you need to subtract with 67.8, the value of x bar, and you will get one value. You will take the root of that, 3.01. Now for calculated value 3.01 substitute, you will get it as 1.89, that is less than 2.262, which is 2.262 means here they have given, right, this you need to remember, that is less than, so it will be what? Null hypothesis is accepted. these type of problems are almost similar, that is to consider null hypothesis, alternate, and you have to show that it is accepted or rejected. That's it. And the question also which you have to consider will be also given here. What answer will come, you have to compare with this number. Next you have to see, they have given 10 boys IQ levels, and they have given these data is for 5%. Again they have set the value. Again you consider the same, x bar you find out, s square you find out, xi minus x bar, that is for all the IQ level, that is 70, 120, 110. What is the value you have obtained? 97.2. That will be subtracted with whole square and you will get the value as 14.27. That will be what equal to, you substitute here 14.27, yes value. These two already you know, root of n also you know, you got 0.6205. You will get it as less than, so it is null hypothesis is accepted, or you can write it as null hypothesis which you assumed, right? That is accepted. Next is about the chi-square distribution. In the experiment of pea breeding, the following frequencies of seeds were obtained, and you have some round yellow, round green, and wrinkle green, and total is they have given. Now they have to predict that what are the frequencies should be in proportion 9 is to 3 is to 3 is to 1, and you have to show that theory and experimentally. Now first we will take what is the total number of seeds they have given, 556. Okay, now the ratio is what, 9331. If you add that you will get it as 16. Now you consider total is, the ratio is 16, and they have, first you consider for 9 ratio, 3 ratio, 3 ratio, and 1 ratio. And the what is total number of seeds, you have to multiply and divide by the ratio of that. Okay, now you will get some values. If you can do this all in calculator. And next the one table you need to form, that is observed value and expected, and observed minus expected whole square. 315, 101, 108, 315, 101, 108, 38, 32, all are given. And expected is what, see here what you have found out here, that, and you subtract and do the square of that. Next you will take again x square is equal to I is equal to 1 to 4, and you will apply this formula. You will get it as 0.47, that is what, less than 7.815. You can observe the table, you will get this value, that is 0.47. You will get this by doing 7.815 you will get. Next according to this it is less, so it is fitness is good. In this chi-square only 3 types of problems will be coming. This is one type. Next will be Poisson and binomial type. Okay, Poisson is fit a Poisson distribution to the following data and test the goodness for at 5 level of significance. And I have given a x value, and for its frequency x square will be equal to 3.82 with degree of freedom 4. See, now you just find out the mean, that is 0 of 1, that is 0 into 1 into 2 into 3 into 4 into divided by 1000, that is total frequency. Now you will get it, now you have to do according to Poisson distribution. E power minus m power x divided by x factorial is the Poisson distribution formula. I hope you remember. Next, if you substitute the values, you will get it as e power m is what, 0.405, and 0.904, 0.405, and 0.904. Okay. Next is divided by x factorial. Now for the value of x, you substitute 0, 1, 2, 3, 4, and you will get it value. Again write the observed table, expected table, you subtract that and do the square. Now you will get the value again x square, you substitute here, you will get 7.89, which is greater than 3.82, that is not fit for Poisson distribution. As I said, next will be about the binomial type. That means 4 coins are tossed 100 times. Results are obtained. That is 4 heads. Number of heads are, and what is the frequency, and fit a binomial. Value is 9.49. See, they have given value and 3.82, right? You have to compare with 3.82 value. Okay, what are the obtained value? You have to compare. If you see the question clearly here, they have mentioned 3.82, and here also you compared with 3.82. I hope you got it, but if you have not got, I repeated that again. Okay, now here you will compare with 9.49. Again, what, n is equal to what, 4. Here what, 4. Okay, Now probability of getting head. Now if you have one coin, here it will be head, backside it will be tail. Now if you have probability, either it will be head or it will be tail, so it will be what, 1 by 2. This is how you have taken the probability of that. Now again you will take q value, that is 1 by 2, and binomial distribution is what, ncx p power x q power n minus x 4cx 1 by 2 whole power 4. Okay, whole power 4, if you do 4cx divided by that is 2 power 4 is what, 16. Okay, now if you get the value, here you have tossed 4 times, right? So I'll find out up to 4, f of 4. Here just substitute the value of x as 4 and you do the value. That means 100 divided by 16 into 4c x, right? That is 0. Now if you do the value of 4c0, you will get it as what? 100 divided by 16 into 1. If you do 100 divided by 16, you can also do in the calci with me, you will get it as 6.25. The value of this is here, right, written. Again, the same you need to do as combinations, permutations you can do in calculator. No need to worry about finding the values. Again, what you need to do, observed value, expected, and you will subtract that and do the square. You will substitute here and you will get the value 1.2, that is lesser. So it will be fitting. Binomial distribution fit. Okay, next is the last topic in this module is about the f-test distribution. The following table gives the number of units produced per day by two workers A and B for some days. Okay, can we say that the worker A is more stable than worker B? You have to use 5% LOS. Okay, now they have given worker A and worker B, and you have to take the value as 4.88. This they'll only give, no need to worry for all, which we did previously also. You can see in question they have given. Once you need to practice or else you will not get it. Now you have to take the null hypothesis, and as they have, their stability is equal, and you have to take the alternative as stability of A is greater than stability of B person. Okay, now what is the n given? 1 2 3 4 5 6. Here it is 2 extra, that means 8. Okay, n1 is equal to 6, n2 is equal to 8. Now you have to take the value of the value they have given and substitute x1 minus x mu, that means mean whole square. You will get it as 9 49 1 16 1 4. If you add that, you will get 80. Next, if you add this x1 value 222, again x2, again this value you need to substitute. That's it. X, see, I hope you didn't get it. X1 minus X bar they have given. If you, they have not mentioned this X bar, you just add these value. That is 40 plus 30 will give you 70. You do it calci. 40, 30, 38, 41, 38 and 35. You will get it as 222 divided by 6, right? They have given, yeah, 6. 222 divided by 6, if you do, you will get it as 37. This is the mu, that is x bar value. You just substitute, that is 40 minus 37 will give you what, 3. 3 square is what, 9. I hope you got this how to do. I'll erase it in question also so that you will not get confused. The same way you will do for worker B also. Now see the method I said they have given here. You will substitute, and S1 square will be what, sigma of x1 minus x bar whole square divided by n1 minus 1, n2 minus 1. You will get some value. You will now take the FC, that will be equal to S2 square by S1 square. You will get it as 2.8025. The value which they have given was 4.88, that is less than. So accept the null hypothesis. Now the stability of both worker is same. Now the null hypothesis got accepted, right? See, what we considered in null hypothesis here? H naught. That means it is null hypothesis. We considered both workers' stability is same. So we will prove that it is the stability of the both worker is same. This is about the fourth module of M3, that is BCS302. If you want the same PDF, you can DM me on Instagram. Make sure to like, share, comment and subscribe to my YouTube channel. Also do follow on the Instagram page, that is Spotify_learn is my account. Thank you for watching the full video. I'll upload the module 5 video also today. As I said, I'll complete within 28th of January. You can also complete it with today all the modules, means next you can go with OS, DSA or DDCO and all. I'll be uploading all the videos. Make sure to see all it and then you can DM me for PDF if you require. Thank you for watching. Stay tuned.